Hello, I'm Professor Von Schmohawk, and welcome to YU. For tens of thousands of years, people invented different ways of counting things. Things such as gazelles, or coconuts, or people, or days. In mathematics, the counting numbers are called natural numbers. Natural numbers start with 1. There is no limit to the largest natural number. Natural numbers do not include the number 0. When people started counting things, it probably seemed pointless to invent a number for no things. Why would you say the number of bananas we have is 0, when you could just say, yes, we have no bananas? However, once positional notation was invented, a symbol to represent 0 was needed as a placeholder for columns containing no digits. For instance, the number 2009 represents 2 thousands plus 0 hundreds plus 0 tens plus 9 ones. Without the 0 symbol, this number could get quite confusing. At some point, people started including 0 along with the natural numbers. The natural numbers plus 0 became known as the whole numbers. 0 is a number with a unique property. When you add 0 to any number, the value of that number is unchanged. In mathematics, an identity element is a number that leaves the value of something unchanged when a particular mathematical operation is performed. So 0 is known as the additive identity. 1 is also a number with a unique identity property. When any number is multiplied by 1, its value is unchanged. So 1 is known as the multiplicative identity. The existence of a number which is an additive identity and a number which is a multiplicative identity is an important property for a number system. Up until now, we have thought of numbers as quantities. But what if we visualize numbers as distances? If we think of numbers as representing distances from some point, then we can arrange the numbers on a line, like the numbers on a ruler. The point from which the distances are measured is called the origin. It makes sense to place the number 0 at the origin since it represents 0 distance from that point. We must now choose some distance for the number 1. This distance is called the unit distance. Every whole number then corresponds to a multiple of that unit distance. This way of representing numbers is called a number line. Since there are an infinite number of whole numbers, we place an arrow on the right end of the number line to show that it goes on forever in that direction. The natural numbers and the whole numbers both can be represented as points on this number line. Addition can be thought of as adding distances on the number line. For example, adding 1 unit distance to 1 unit distance gives us a distance of 2 units. Adding a distance of 3 units to a distance of 4 units gives a distance of 7 units. Likewise, if we subtract a distance of 4 units from a distance of 7 units, we get a distance of 3 units. When any 2 whole numbers are added, we always get another whole number. Therefore, we say the whole numbers are closed under the operation of addition. A group being closed under some operation means that the operation will always create a result which is also a member of that same group. But are the whole numbers closed under subtraction? If you subtract a larger whole number from a smaller whole number, there is no whole number which can represent the result. This is because we would need a negative number to represent the result, and whole numbers do not include negative numbers. Therefore, the whole numbers are not closed under subtraction. However, if we expand our collection of numbers to include negative numbers, then we can always find a number to represent the result of any addition or subtraction operation. These whole numbers, which can be positive, negative, or zero, are called integers. No matter how we add or subtract integers, the result can always be represented by some integer. Therefore, integers are closed under both addition and subtraction. You may be wondering what a negative number actually means. As recently as the 18th century, negative numbers were not accepted as legitimate numbers by many mathematicians. It was thought that only positive numbers represented things in the real world. However, the idea that negative numbers don't actually represent anything in the real world is debatable, as anyone who has ever overdrawn their bank account can tell you. Someone who owes more money than they have could be thought of as having less than zero money, or having a negative net worth. Death Valley is below sea level, so the altitude of Death Valley could be thought of as a negative altitude. A vacuum cleaner creates an air pressure which is less than atmospheric pressure, so it can be thought of as creating a negative pressure. Integers can be represented on a number line just like natural numbers and whole numbers. But now the number line must go off to infinity in both directions. With a positive or negative sign, a number can be thought of as representing not only a distance but also a direction. Just as a positive number can be thought of as representing a distance to the right of the origin, a negative number can be thought of as representing a distance to the left. Adding a positive integer means moving that number of units to the right. For example, if we add a positive integer to the number 2, we start at 2 on the number line, and then move that number of units to the right. Adding a negative integer means moving that number of units to the left. In fact, adding a negative number is exactly the same thing as subtracting a positive number. So we can think of subtraction as just the addition of a negative number. For example, the problem 2 plus 3 minus 6 minus 2 plus 4 are instructions to start at 2 on the number line, then move to the right 3 units, then move to the left 6 units, then left another 2 units, and finally to the right 4 units. At the end of the journey, you will be at the 1 position. So far, we have seen that adding a positive integer means moving that number of units to the right. Subtracting a positive integer means moving that number of units but in the opposite direction. We have also seen that adding a negative integer means moving that number of units to the left. So subtracting a negative integer must mean to move that number of units to the right. Subtracting a negative number is the same as adding a positive number. The distance from a number to the origin is called its magnitude or absolute value. For instance, the numbers positive 3 and negative 3 have opposite signs but the same magnitude since they are located the same distance from the origin. If you take any number, positive or negative, and add a number of the same magnitude but the opposite sign, the result will be 0. This number of equal magnitude and opposite sign is called the number's additive inverse. Any number plus its additive inverse is 0. For example, the additive inverse of positive 3 is negative 3. And the additive inverse of negative 3 is positive 3. With the invention of integers, we now have a much more powerful number system. Since the integers are closed under addition and subtraction, we can represent the result of adding or subtracting any numbers in our system. However, as we shall soon see, there are still some operations which cannot be represented using only integers.